During the month of July, scientists and engineers from NASA and the Canadian Space Agency, in cooperation with Pisces and the University of Hawaii, visited Mauna Kea for a 2-week analog test. The purpose of the test was to simulate a mission to the south pole of the moon, where the lunar rover Resolve will search for, harvest, and process water into consumable resources. After the test was successfully completed, the rovers were packed up and brought to the Imiloa Astronomy Center on the campus of the University of Hawaii at Hilo, where the community was able to interact and learn about the mission.
How would I design the mining equipment to recover that water? And by knowing how deep it is, what's there, we can, for the next mission, go back and design the right instrument to go in and harvest that resource that's there.
Today we're here at the Imiloa Science Center on the campus of the University of Hawaii at Hilo, having our public outreach day for our very successful analog test. These analog tests are done in very remote areas and very pristine environments, which is the value for doing the testing. And it's very hard to get the public and, as you can see, all the young children, keiki here. So we come down at the end of our test and share everything that we've brought over with the public.
Keiki were able to get up close and personal with scientific equipment that will be included on a future mission to the moon. They were able to see, touch, and even drive a rover that was involved in the analog test on Mauna Kea.
So this is Artemis Jr. This is a Canadian rover developed by the Canadian Space Agency in a partnership program with NASA to carry the Resolve science payload. The motor on each side of the vehicle controls the wheels on that side of the vehicle through a 2-stage chain drive in the black drive unit between the wheels. The electric motors are powered by batteries, which are housed in the chassis rails on the side of the vehicle, and by turning through the gearbox, the chain, they control each individual wheel and each pair of wheels, and therefore the rover can drive forwards by turning both pairs forward simultaneously, backwards by turning both pairs backwards simultaneously, and it can turn on the spot or at an arc by turning the wheels in either different directions or different speeds. The rover can be driven remotely through a handheld device on the ground or at a control station somewhere at a distance. It can also be controlled autonomously using navigation software which runs on the rover. The processing on the rover is done by 3 single-board computers, each with a quad-core i7. It takes a lot of processing power to run through the autonomous navigation software that we have on board. The rover can be programmed to go from point A to point B, or from point A to point B to point C and on, multiple waypoints. And as it's going from point A to point B or any step along the traverse, it will autonomously detect new obstacles or existing obstacles and traverse around them, avoiding obstacles that it knows are too great for it to surmount using the geometric suspension. The suspension works by allowing the wheels to walk up and down, rotating about the spindle, which you can see below the motor on each side of the drive unit. This allows for terrain compliance and terrain following without the loss of efficiency that you get from a more active suspension system.
And the reason we chose Pu'uai Wahine Valley is that the tephra, or soil, is very similar to the lunar regolith, or lunar soil, in its magnetic and electrostatic properties. And the difficulties you'll see in the lunar environment stem from the fact that the soil gets everywhere. It gets into your gears, into your motors, into your electronics boards. It will clog your filters. It will get into your valving systems. And so in order to understand how we would deal with those difficulties, we needed to test in a lunar-like environment. You can't usually just put dirt in a laboratory. They kind of frown upon that.
Artemis Junior is equipped with a portable chemistry lab which includes a neutron spectrometer and a near-infrared spectrometer which can detect the presence of water up to a meter below the surface. After a sample is taken, a mass spectrometer and a gas chromatograph are used to analyze gases that are removed from the sample. It is a process that has evolved over many years and many different designs.
So what we have here is a series of reactors, and the purpose of these systems is to try and find a way to extract water from the lunar dust. And so these are 3 different generations and 3 different approaches for trying to do that. Our first system tried to mix the dust using hydrogen gas flowing at a rate that's fast enough that it'll keep the dust actually mixing. So if you actually see that process, it kind of makes the dust look like a liquid, and that allows us to heat it really nice and keep everything uniform. So that's what this method was, and we would recycle the gas, make water vapor, and capture it so we could quantify it. This version, we slowed down the gas rate a little bit and used an auger to keep the dust mixed. Now, recently we've now known that there's actually water ice on the moon, so now we are looking at the process for extracting the ice that's already there. The problem is the water that's already there is extremely cold, and so in order to keep that water, or to try to extract it, you have to have a system that can accept really cold samples and not let the water out. So this system is designed to drop down to the same temperature as the ice, and then take that sample, which will come from the drill, and take it into a reactor where it gets sealed, and then we heat it up and drive all the water off, and we can quantify that water. That's the idea.
Much to the enjoyment of the children, NASA brought some equipment just for this outreach event.
Well, what we see here is an educational robot, and this is being used courtesy of NASA Ames Exploration Uplink, and it's called Uplink because through the internet anyone can control this.
Exploration Uplink is a partnership between the NASA Lunar Science Institute, NASA Spaceward Bound, the NASA Ames Intelligent Robotics Group, and the NASA Ames Education Office. It is an outreach project designed to engage students by bringing hands-on field science and space exploration into the classroom using NASA telerobotic systems. These robots use communication systems that are extremely similar to those used on Artemis Junior. This technology allows students with internet access to operate NASA's spaceward-bound field science rovers from anywhere in the world.
And you have to press the button so you get, and you can control the little camera.
This outreach event marks the end of one test, but it won't be the last. The Pacific International Space Center for Exploration Systems, or PICES for short, is a research and education center dedicated to the development and implementation of new technologies needed for operations on the Moon, Mars, and beyond. It is currently situated on the campus of the University of Hawaii at Hilo. It is just one more reason our community on the Big Island is special.
This is just another aspect of what we're trying to do, to create jobs, create opportunities for young people, and making programs available for young people that are studying here, and not only our local kids, but others throughout the world. They come here to the University of Hawaii Hilo, study about whether it's volcanology, aerospace, and so forth. And I believe that PICES is a huge step in that direction.
PICES is the host for this test. They provided us with they worked through the logistics of obtaining the permits and things of that nature. They provided a great set of students that have been out here working hard to prepare the test site for us. And we've even had some of those students in the control room with us, helping us, teaching them how we need to process the data. So without Pisces, we wouldn't be here, and they contributed a lot to the field test here.
The Big Island of Hawaii is truly unique. It is a place where science and culture combine in perfect harmony for the benefit of those around the world, and perhaps, in the not-too-distant future, the entire universe.